Hi everyone and welcome back to the series Build a Large Language Model from Scratch. In this video, we discuss about an simple self-attention mechanisms without trainable weight. So in the previous video, we discussed about the attention mechanism in details. So now let us start our journey. So let us start our tutorial by taking here one example sentence. Let's say your journey starts with one step. So what we basically do in our previous tutorial, we convert this sentence into some kind of tokens and also give here some kind of token ID as well as we initialize with the embedding vectors. Okay. Now after that, we are going to using here the self-attention mechanisms. The self-attention mechanism in this video. So what you can do basically, we are going to converting this sentence into one embedding vector. That's embedding vectors, and after that this embedding vector is going to convert it into one context vector. It's called context vector. So using context vector we can pass it to the attention mechanism, because attention mechanism just only seeking for this context vector. Now why this context vector is needed, as well as why you need to do that. See, if I taking the same example, your journey start with one step. So if I convert them into the token IDs and the embedding, so the informations is not captured. So in our case, because using these attention mechanism, we basically do the next word predictions. Okay, next word predictions. So in the case of next word predictions, we need to first know about the how the word is far from this actual word. Okay, because you need to learn about the entire scenario, then we can predict the next word. So if I taking this example again, then I will teach you in details. Let's say your journey start it says starts with one step. So you don't know that how this word called journey is related to this word, this word, I mean the with, and this word and this word. How it is important to start, how it is important to the one, or how it is important with respect to the steps. We need to calculate here some kind of attention score. We need to calculate here some kind of attention scores. So if I go in the book sections, so in this book you can see here one the pictures. Your journey start dot dot steps input vector token embedding that we already created in our tutorial number 1, 2, 3, 4. So we need to convert them into some kind of token ID that you can see. And then you also denoted it x1, x2, x3. That's our variable name for these token embeddings. And then you can see here it have also an attention weight. Attention weight to weight the importance of x1s. So this alpha 2 1 is for the attention weight for the years. This alpha 2 2 is the attention weight for journey. The alpha 2 3 is attention weight for a start. Same thing for these ones. Now this is the context vector that you need to create it, that you see. So we're going to convert them into token ID, and then it also convert them into one kind of context vector so that we can pass it to the our attention mechanisms. Now you can see here JAT2. The context vector JAT2 is the computed as a combinations of all input vector weighted with the respect to input element x2. See again, it's respect to input element x2. That's mean we are going to calculate here the attention weight as well as the context vector for the journey. Okay, I just take it here. So for the case of journey, what are the attention score, what are the attention weights? Okay, that's when you're going to calculating for the each of the word. So I just take it for the journey word. So from the journey word, how far the word is, or how far the word studies, or how many attention score I can give, or how many attention weight I can give. Okay, that's the reason, right? That's the main thing, right? So what you can do, I am going to copy here one code that you can see. We have 0 0.4, 0 0.1, 0 0.8. This is nothing but the token ID. Okay, the token, sorry, token ID, because so not token ID, you convert them into input vectors, token vectors. See, the goal of self attention is to compute a context vector for each input element that combines information from all other input elements. See, that's mean we are going to see here the word called journey with respect to the other words, and after that we see all our whole data sets that you need to create. You can see, for example, consider an input syntax like your journey start with one step, that you can see. In the case, each element of the sequence such as x1 correspond to the d dimensions, that you can see d dimensions. Okay, we just take it the three dimensions for the sake of the simplicity. And you can see, let's focus on the embedding vector, that you can see embedding vectors. And then you also have the context vector, that you can see jet2 for the journey word. We just take it the example as a journey word, and after that you're going to combining all of them. Okay, now what I can do is simply going to write in the codes. So I need to go on here. So I'm going to pasting here one code that I copied. Actually, it's nothing but for drawing the floats. Okay, so this is the code for drawing the float, as well as I'm going to copy this code from here. Okay, not actually these ones. I need to copy here this thing because it's needed at all. I'll discuss it. Okay, no problems. So we first import here the torch, and then we're creating here some kind of inputs. So you just take it as the three dimensional vectors for the use, and journey start with one step. That's for simplicity. Okay. So in our GPT and GPT-2 case, it's nothing but a 768. You also see in the book, it's called a D dimension. You can see D dimension, right? You can see. Okay. So for the case of you take in here the token ID with the three dimensions. Same thing for journey, start with one and step. Okay. I am simply going to running this out. And after that, I'm going to also running here this code as well, so that you can see one thing. You can see one thing. So you can see here, if plotting here those of the data in a 3D plot. So you can see how this word journey is close to word start, close to start, as well as you can see how this your is close to step. But in our case, we're just taking here the example in the case of input journey. So to calculate here how far the what step is, or how far the what one is. So it's quantify how the two vector are actually aligns, that you can see. Okay, how it aligns. So in those case, what we actually use. So if I go on the this again, then you can see actually. So it's just taking here the word at journey as our base sentence, journey. So we need to creating here and graph. Let's say creating here one basement graph. So here we have our word journey. Okay, then we have our word called start. Then you also have another word called with. Then also you have another word called the your, as well as this one. Okay, now I need to actually calculate here the distance, or you can say not distance. Actually, I need to calculate here the alignment. I need to calculate here the alignment. Now, why alignment actually? Why alignment actually? If I go in the book, then you can see this thing. See again, your journey start. See, the embedding query token is one of the embedded input tokens. Here, the query is the second tokens. I mean, we're just taking here the journey as my query tokens, and based on that, I need to calculate here one more thing that's called the attention score. I have to calculate here one more thing called the attention score. That's called omega, or you can say W, W21, W22, W23. So it's a attention scores. Now, if I take in the word called journey as my query, based on this journey, how the word far is, how far what is, okay, that you can see. So you need to calculate here the attention score. This is the middle one. Okay, this is the middle one. So since self-attention, context vector play a crucial role. Their purpose is to creating here and rich representation of each element in input sequence, that you can see. So this is essential for large language model, which need to understand the relationship and the relevance what in a sentence to each other. So that's why I need to creating here embedding query token for that. So if I taking here the word called journey, and for in the respect to the journey word, I need to also calculate here the attention score for the each of the word. Journey to use, journey to start, journey to stop. So for this case, how can we get the alignment of the vectors? How can we get the alignment of this vector, two vectors? we can basically get in the alignment of the two vector using the dot product, using the dot product, right? Using dot products. So you can also implementing this out, right? You can also implementing this out. Then you can say that how this word is related to each others and how many attention score I can also give. So in our case, we can see the journey and the start word. If I see in this graph, journey and starts word are have the low angle. So if I write down the equation of this dot product is nothing but a b and a cos theta. This is the value. So if have the high alignment, that's mean it have the high correlations. It have the high attention score, right? Now we can implementing this one. Now let's implementing this one. So it's better we can simply go to removing this one because it's not needed at all. We can directly quote on here. Okay. So see, now we need to also do the dot product of the each of the data points. Okay. Now let's go on here and let's go on the full screen mode. Now what I can do, I am actually going to draw the code from this book, this build a large language model from Scala that you can see. It's in front of me. Now we need to taking here one query. Okay, let's say taking here the query. So we are going to taking here the query as our inputs of one. So inputs of one is nothing but mean the journey. We're just taking this journey as a base input, base query. And based on this base query, you're going to calculating here the attention scores. So how can we complete here for the one word, and after that you're going to calculate for the from the start to all of the with respect to all of the word, step to all of the respect to all of the words, same like that. Okay. So just taking the journey words. So my query is nothing but the inputs of one. Now I have to calculate here the attention score because this is the middle part of the context vectors, right? After embeddings. So what I can do, you can say that attention score. Let's say attention scores. So attention scores of 2. Then you can say that you're going to creating here and torch.empty. And then after that, we're simply going to microphone थोड़ा ज़्यादा बाहर गया है एक्चुअली. मैं थोड़ा इधर पर चला रहा हूँ ना, मेरा माइक्रोफोन चेंज करना पड़ेगा. मुझे लगता है साउंड इतना अच्छा नहीं होगा, बहुत साल पुराना है एक्चुअली. So then we are going to give it here the input shapes. Okay, input shape. Okay, because you need to creating here an empty torch. Okay, for that. So if I want to printing this out, then you can see it. Let's say attention score 2, attention score 2 for the number 2. So why I give it here 1, because Python index is start from the zeros. So you can see it's tensor with full of the value of the zeros that you can see. Now we need to also calculate here this attention score. So how can you calculate it? So we need to calculate it to the dot product of the this query sentence to the all of the word. So the query word to the all of the words. Dot product of the all of the words. So if I are taking this query as a journey, so if I calculate the word called steps, I have to take in the dot product of the steps and dot product of the journeys. So what I can do, we can iterate to all the below from here. So we can simply going to say that, let's say for, and we can enumerate it. Let's say xi. I just take it to the xi because we denoted it in our book. It's called x1, x2, x3. So I just take it to the xi. Okay, xi. And then in enumerate, let's say enumerate. And then you're going to passing here all of the inputs. Okay. Now after that, you're going to taking the dot product of that. Let's say torch dot product of the xi. So x is a different value. It can be the step, it can be the u, it can be the width, it can be the start, as well as it can be the ones. So what I can do is simply going to passing here the query. So based with respect to this word called journey, we're going to calculate here the attention scores. So let's say attention score. Let's say attention score. Okay, attention score 2. Okay, so you're simply going to uh, store it. Let's say I is equal to this one. That's it. Now you can printing here this attention scores. So by default, it the value at the value as nothing but the initialize at the 0. Now if I checking here the attention score 2, then you can see here it full up some kind of value. 0.9544, 1.4950, 1.4754, 0.8434, 0.707, and 1.865. So the first word is called the yours that you can see. The first one yours is the value is 0.95. Okay, if I calculate the dot product of the yours, you can see here 0.95. So same thing, if I see the journey word itself, so it's nothing but 1.4950, the high ones. Okay, now if I calculate the word for a start, that you can say start, so it have the lower angles, that's why value is quite big. 1.47 is quite it's near to the 1.49. And then the another word called the width. Okay, width, so it is quite far, not so far actually. And you can see 0.843, 0.75, and also 1.065. Okay, it's nothing but the steps. Okay, that you can see steps. So to creating here those attention score below. Now, why this dot product? See, dot product is nothing but for the alignment. Okay, right? Now, after that, what we need to do basically? So we need to do the normalizations. We need to do the normalizations. If I see that this is the part about the attention score, and after that, we need to normalize the data. So why normalization is needed? You know, in the case of the machine learning as well as in the deep learning. Okay, so how can we basically do the normalizations? So normalization, the main goal of the normalizations is to obtain the attentions where that sum of the zeros, so the sum of the ones. Because we need to making all of the values the range of 0 to 1. If I see the attention score, that you can see it's which is not lies between the 0 to 1. So to normalize the value like that, if the value is lies between 0 to 1s. So this is the case, and it also follows out. So how we can actually normalize the value? We can simply go into taking all of the value of the this word attentions, and then you can simply go into divide them with the summation of that. Okay. So how can you do that? Let's go on the code sections and let's implementing this on. So this is called the normalization part. So what I can do is simply going to normalize our attention score. Let's say attention score 2, and then we are going to divide them with each value of the attention score dot sum. If I normalize the value called 0.95, I take in this just this value and divide them with the summation of this full value. So the summation of the full value, I don't know how is it, but I am just going to divide in them. So if I divide them, the summation of the whole value with the one single value, so the range is lies between 0 to 1s. Okay. Now what I can do is simply going to store it inside the variable called attention weight. That's attention weights. I can make it as a 2 temp. Okay. See, in our book, it's also represented. We have to calculate the attention weight, that you can see attention weight from this after this normalizations. Okay. Now you can simply going to say that printing here the attention weights, and then you can say that the attentions weight temp, and then you can also printing here the summation of that. Okay, let's say summations. So summations, and we can say that's attention weight temp dot sum. So you can see here summation is ones, and you can see the weight is lies between the 0 to 1s. Cool. Now let's go on the board again. Let's understand what is actual normalization and how can you do that. हमने तो कोड कर लिया, लेकिन तो समझना पड़ेगा ना बस. So normalizations. So normalizations mean value lies between 0 to 1s. Okay. So let's assume that we have a sentence called what call sorry, not what, actually we have a uh, number called 1, 2, 3, another one called, let's say, 500. So if I normalize it, what I can do basically, we sum up all of the value and divide them with each value. So the sum of the value is nothing but, let's say, 506. So you need to divide them 506, 506, 506, and again 506. So if the number is quite big, so you need to divide them with a bigger number. If the number is small, we need to also divide them into a big number, right? That's mean it computationally quite expensive. Yeah, so you see that if we have the large amount of data, we need to also divide them with this actual value, with this value. So what we can do? So you can using here an activation function called softmax. So using softmax activation functions, we basically do the normalizations. We can basically do the normalizations. So in the case of softmax, what actually happened? So if I considering this word call, let's say x1, the x2, the x3, and up to xt, that we have, that we have the your journey with one step like that. Okay. So we're just taking all of them. So if I apply here the softmax, if I apply the softmax, okay. So what will be? It should be the e to the power x and by some, okay, because if we see the equation of the softmax, okay, if I see the equation of softmax, you can also go. So this is the formula of the softmax activation function that you can see. So this is the formula. Basically, it's used for the multi-class classifications. So you can see one exponential term. Okay. So same thing in our case. Same thing in our case. We have this exponential of the x1, and we need to divide them with the summations. So we need to also same thing, do the same thing for the x2, the summations, and same x2, the summations. Okay. So it's quite a big number, right? It's quite a big number. But instead of using here the normalizations, we can basically use the softmax. But internally, if I using the PyTorch, if I use the PyTorch, so in internally PyTorch using here the equation like that, let's say if ex1s and minus the maximum value and divide them with the summations. Okay. So it would actually dealing with the overflow problem. It dealing with the large value. Basically, when it happen about the overflow problem. Okay, it actually follow this out. So you can also use here the softmax, just instead of divide them with the total numbers. Okay, so let's using these ones. So what you can do, you can simply going to go on here, and then you can easily creating here functions. So let's say def softmax. That's a type, and then you're going to passing here a parameter called x, and then you can simply going to returning here, let's say torch dot exp of the x, and then you can divide them with the torch dot, let's say torch dot exp of the x dot sum, and you're going to passing here the dimensions as the 0. Okay, in this way, I mean you're going to calculating here in the case of the in the row. Okay, and after that you can simply going to calculate here the attention weights. Okay, let's say attention weight, it's a weights to so weights to knife, and then you can simply go into using here this softmax that you created. Okay, and inside that you can passing here this attention score 2 that we have our, that you can see, and after that we simply going to printing this one attention weight and the attention weight sum. Okay, I am just going to print this out, and then I'm going to copy this out, and instead of that I am going to paste it here this attention to knife, so that you can see you got the same value. You can see 0.155, the same thing you can got on here, but in here we got here the 0.1581. Okay, but in this cases we got in here the value as a 0.1656, but in here we can got 0.1581. Okay, that you can see, and summations of that is nothing but here the ones that you can see, that you can see. Now we can also using here the PyTorch one, that is the building library. So you can copy this out, and then you can simply go into using here torch.softmax, and then it also give it here the dimensions. Okay, in the which dimension I need to apply. Okay, so same thing you can see 0.135 and 0.1581, that you can see. We're using here the PyTorch softmax activation functions. Okay, now let's go on the book again. Then you have our next part, so that you can see already implementing all of the things. Okay, now our next part is about the attention weight, that you can see our next part is about the attention weight. Now how can you basically calculate here the attention weight, and after that you can calculate here our context vectors. So you have our word called your journey starts. Now you need to calculate here the attention with alpha 2 ones. So you need to multiply each input vectors with the corresponding attention with. You have to multiply with. You have to multiply with the corresponding attention weights. Now, how can you compute here the attention weight for the input tokens? How can you compute it? How can you compute it? So we basically actually crossing this out, cross this attention weight to this input vector, and after that we can got in here our context vector, right? Let's do it. So what you can do, we can simply go into writing the code for that. Let's say taking here the query. Let's say our query is nothing but the inputs of one, because we're taking the word called the journey. And after that, you're going to creating here the torch dot zeros, all of the values about the zeros. And then you can passing here the query dot shape. That's our query. And based on the query, we are going to creating here one context vector. Let's say context vector of the two. Okay. Now after that, you're going to enumerate all the value. Let's say xi in enumerate, and then you can passing here the inputs. Now you need to calculate the attention, sorry, context vector, right? So how can you calculate the context vector? We're going to multiply the each input vector. See, multiply the each input vector with the corresponding attention weight, with the corresponding attention that you gained. So you have our attention weight that you can see. You have our attention weight. So how can we calculate it? How can we calculate it? So we can join them. That's the context vector. See, context vectors. Why join? If you see this thing, we need to calculate all of the attention weight, multiply all of them, and join them. And join them. Then we got the context vector of the jet2 of the word called journey. Okay. So let's say I'm going to using here. Let's say context vector 2. Then we join them, and the attention weight. That's our attention weight. So we can using here attention weight 2. So we can using here, let's say this is not knife, so we can make it as attention weight 2. Okay. Now let's make it here attention weight 2. Then we simply going to using here the each of the word with each of the word with the x and I attention weight of the each of the value multiply with all of the values. See, multiply all of the values. Xi is nothing but your, again step, again journey, again with, right? Now we can simply go into printing this out. We can simply go into printing here this context vector. Let's say print the context vectors. Now you can got here on context vectors. We got here one context vector. If I calculate, if I wanted to calculate the context vector for the word call 1, so I need to give it here 0, 1, 2, 3, and 4. So if I change in this one to the 4, that you can see, if I change this word call 4 at my query, so this is nothing but my attention score. This is my normalizations. This is my normalization. This is my attention weight. And if I using this word call 4, and this is my context vector for the word call 1, the word call 1. Now we need to calculate the values, for all of them, Now how can we basically compute the attention weight for all input token? Okay, so if I go in the book that you can see, let's say I have the word called journey. So it's related to call what yours, I mean how much attention weight we can pay. It's 0.13. Okay, 0.13. And how much attentions weight we can pay for the journey to journey, it's nothing but 0.23. How many attention weight I can pair to the word color starts at 0.23, and how many attention weight I can pair with this word color with 0.12. So this is one kind of vectors. So this is nothing but our thing that you need to follow. You need to first follow compute here on attention scores, then compute the attention weights, and then we compute the context vector that we already done. Now we need to it for each and every sentence that you can see. We just go this for one sentence. I need to creating here it for the every sentence that you can see for a year, for a start, for with, for one, for a step. That's it. That's it. Our tutorial is also going to end. Now we're simply going to calculate each of them because we have the 6 cross 6 matrix. I just take it for the simplicity. Now what I can do, let's go on the code. Let's go on the code. Simple as it, right? Now we simply going to creating here, let's say attention score. Let's say attention score. And then you can say that torch dot empty, and we can passing here 6 cross 6. Why 6 cross 6? Because you can see in the previous we just get here input shape of the zeros, because in our case input shape is nothing but 6, just one simple matrix 6 cross 1. That's why just give it here 6. Right now our context vector should be the 6 cross 6 that you can see. That's why we need to also creating here the attention weight for the 6 cross 6 that I give it here as part of my result. Okay, now what you can do, we need to we need to calculate this value. If you want to plotting this graph, sorry, plotting this grid, I need to using here the two for loops. I have to using two for loops. It's the basic thing, right? If you want to do one kind of patterns, I have to obviously using the two for loops. So because of it's nothing but one kind of things that you can see the 1 1 1 1 1 1 like that. So I need to using here the two for loops. If you know the basics of Python, then you can obviously do that. Okay. So let's see this one. How can you actually creating here a square shape like that, the context vector. So let's say for I in, let's say, range. So you can say that let's say 0 to 6. And then you can creating here j in range, let's say range, let's say 0 to 6. And then you can simply printing here the j. And then in the end, we can simply going to give it to here. And then you can simply going to printing it out, the blank space. So you can see here 0 1 2 3 4 5 6. So you can also give it here some kind of space. Okay, yep, right here you can see 0 1 2 3 4 5 6. Okay, like that. So same thing I'm going to apply it on here. So what you can do, let's say for I and xi, because you have the xi in enumerate, and then you're going to passing here inputs. Okay, because inputs is nothing but 6 cross 6. And then we have for j xj, okay, xj in enumerate. And then you can say that let's call inputs. And after that you're going to calculate here the attention score. That's our attention scores. And here to give it here I and j, to give it here I and j. If we need to store it inside a list, obviously I need to creating here we need to store it inside a list itself. Okay, I and j. Then you can say that torch dot, that's a torch dot, I can using here the dot product, that's a dot product of x comma I. Then I can using here x comma j. Okay, then our attention score is also stored, so we can printing this out, we can printing it out. Let's print here the attention score. So you can see the attention score like that 0.9995, then 0.9544. And you can also see this thing is similar to the above code. You can see 0.95, 0.95, how is it? Okay, it's not here because we remove it. If I see the 4 1, you can see 0.4567. This line and this line is same. This line and this line is same. Just take it here, the one, single one. So instead of doing this one, you can also do one more thing. You can either do, you have to calculate the attention score. Let's say attention score. You can use his inputs, and you can also transport of that. Okay, inputs dot transports. Okay, then you can simply going to calculate the attention score using here this one. Okay, so this one, same thing you can see the same thing. Okay, you can using instead of using the for loops, because it's quite the time consumes, and the time complexity is not a big whoop and scared, so it's better you can using here these techniques. Okay, now you can see we can easily visualize them, that you can see. Now to apply here the softmax activation function, right? So what you can do, we can simply going to apply it here. Let's say torch dot softmax, and inside that you can passing here the attention score itself, because we already have our attention score. So let's say attention scores, and then you can pass in here dimension as the -1, because right now you can see here it had the 6 cross 6. Okay, so you can simply going to store the attention weight. Let's say attention weights, because after normalization we actually getting here attention weights. Now you can simply go into printing here this attention weights, so that you can see attention weights. So same thing you can see at the attention weight. Okay, and you can also draw the summation, and you can check in this what if you join them, the all the value is one or not. Okay, so you can simply go into sum it out, and you can pass it to here, and then after that you can say that it's nothing but the sum. So this is the row number 1, or you can say row number 0. So you can say row number 0, let's say sum. Okay, sum. Then you can simply go to printing this out. Okay, let's try to print. Then you can say row, and then you can say that this is the row 0 sum, and then you can also print it out here, let's say all row sum. Okay, let's all row sum, and then you can simply go into using here the attention weight dot sum itself. Okay, and you can passing here dimension is the minus ones, all the dimensions. So you can see row all of the values nothing but 0.9999. Okay, if I am going to using here the 2, let's say 0.851. So if I am using this one, and you can see all the tensor values nothing but the one itself. Okay, yeah, let's say if I using this one, and you can see row value is nothing but 1. Okay, 0.99, 0.1 is something like that. So if I make it 2, let's say 2, and then you can see the same thing. The attention weight is nothing but the 1 itself if I join all of them. Okay, cool. So you can also calculate the attentions, the context vector. So let's say all context vectors. Okay, let's say vects. Okay, so we can using here this attention weight that we calculated, and with the inputs that you have, now you can printing here the all of the attention weights. So you can see here the attention weight of that. Okay, all of the attention weight that you already calculated separately for the word called journey. Okay, that you can see we calculate the separate word for the number 4. So this number is, and this number is similar, that you can see. So now you can also do the previous the second one. You can printing this out. Let's say print here the previous the second context vectors, and you can simply go into printing here this context vectors. Okay, let's say context vector 2. So you can see here 0.4671, this one and this one is the similars. Okay, so this is all about this tutorial number 5. Is nothing but about the simple self attention without the trainable weight. See, we don't add here any kind of trainable weight in here, so we are unable to training this out. But we need to also training this out, right? So in the next tutorial, we see that how can you implementing the self attentions with the trainable weights, so that you can training this out. So how you train this out? Obviously, our machine learning models, I mean, our transformer model will run something from our data. It's nothing but the raw things that you can see. You just calculate here some kind of raw data, some kind of raw attentions. Now you have to also training this out so that it can do the back propagations. It can change the parameters. Okay, it can batch fit into the data. So that's it for today. Now I hope you enjoy this full tutorial and as well as the full series. So make sure to subscribe to the channels and share with your friends. So I'll be back with the another tutorial. So till then, take care and bye bye.